Hey guys, in this lesson we're going to talk about how to solve log equations. So these are equations with logs in them. Our steps are going to begin with getting the log by itself. So things may be added or subtracted or multiplied with the log, and you want to get the log by itself. This may also mean that you need to use the properties of logs to combine down to one logarithm. Then you're going to put that equation in exponential form and then simply solve for x. Okay, I'm going to do quite a few examples, so if you feel like you need to watch part of this video, pause it, take a break, and then finish, feel free to do that. So example 1, I already have the log by itself, and so this is a basic kind of example, and I'm already to the point where I can put it in exponential form. If you will remember, when you're looking at a log, if it doesn't have a base, that is understood as a 10. So if I go to exponential form here, I have a 10. The exponent is the power of 2, and it should equal the x. Now obviously I can figure out what 10 squared is. So 10 times 10 is 100, and my x is equal to 100. Moving on to example 2, our log is already by itself. Now there can be other things here, like I have 4x here, but there's nothing outside of the log on either side that I need to get rid of. So I am ready for exponential form. So again, I want to look at this, and I also have an understood base of 10 in this problem as well. So I'm thinking 10, and then our exponent will be 2, so 10 squared will equal 4x. So it's kind of similar to the last one. And now I know that 10 squared is 100, but this time I have it equal to 4x, and this is just your basic equation. So the way to solve for x is by dividing by 4, and I will cancel out. So x will be 100 divided by 4, which is 25. Now example 3 is the first one I'm coming to where I do have something to get rid of. This 2 in front of the log, we learned in the properties, could be written as an exponent on the x, and I could say that was x squared. But it's actually easier when we're solving equations to treat it like 2 times something and divide by it to get rid of it so that it will cancel out over here, and that will leave us with log x. On this side, you'll reduce 2 over 2 is 1. And then you have the log by itself, and we go to exponential form. So again, I have a base of 10. This time the power is 1, so 10 to the first will equal my x. And obviously 10 to the first is just 10. So in this case, x will equal 10. Now example 4 looks different because you have 2 logs. And our first directions say to get the log by itself, but how do you get it by itself if there's 2? This is where the properties of logs that we learned in the last lesson, or a couple lessons ago, is going to come in. When you have a minus between them, you know that you can back that up as a fraction. So I can use the properties of logs to rewrite this as log of 3x on the top over a 5 on the bottom. And it will still equal 1. I'm not messing with that side. And at this point, I am at the ready to do an exponential form because I have the log by itself. So my base is 10 again, the power is 1, and that should equal 3x over 5. So I know that 10 to the first power is just 10, so I'm going to erase that so I can think of it just as 10. It does not like me erasing. All right. And you think about how you solve an equation. Well, I've got this fraction with a 5 on the bottom. I need to get rid of that 5. So I'm going to multiply both sides by 5. It's going to cancel out here. And I have the 3x left. On this side, I'm going to do 5 times 10. That's going to give me a 50. And then finally, I need to get the x by itself by dividing by 3. So we will cancel over here, and 50 divided by 3 is about 16.67. Okay, so it's roughly that. I'm rounding off here. You could also go with a mixed number if you choose. So this would be my final answer for example 4. Now, for example 5, when you're looking at it, it looks like something that you want to use properties of logs on. But we're not actually going to do that, because the 5, although there's a plus between it and the 2x, it doesn't have its own log. So you have to look at this as log of this whole piece. That's why the parentheses are there. So as crazy as it looks, the log technically is by itself because there's nothing in front that I need to divide by. There's nothing past the parentheses to add or subtract or combine with logs. So I'm going to go to exponential form. And again, I have a base of 10, and I'm going to caution you that not always are you going to have problems with base 10, but it's easy to learn with. So here I have a base 10, the power is 3, and it will equal 2x plus 5. It equals that whole piece, and at this point you can drop the parentheses. Now I know that 10 to the third power is 1,000. So if I'm going to solve this equation, I'm looking at it just in the normal way of subtracting 5 from each side, trying to get that x by itself. Okay, so I have a 2x over here and a 995 on this side. And again, trying to get the x by itself, I need to divide by 2. So 995 divided by 2 will give me x equal to 497.5. So that would be my answer for example 5. Example 6 again has 2 logs that I need to combine, and I use those properties of logs to combine them. So in this case, I'm not going to divide by 2 because I don't have a 2 with both of these pieces. I'm going to use those properties to put them together first. The minus tells me I'm going to go to a fraction. So I'm going to say log, and then I'm going to have my fraction bar. I am going to think of this as x squared on top and the 3 on the bottom. And when I do that, I have transformed it into a single log, and I'm ready for exponential form. So my base is 10, my power is 1, so I'm not going to write that. And then I have x squared over 3. So 10 to the 1 equals x squared over 3. Now again, the goal is to get the exponent the x by itself, get rid of the exponent, get rid of the 3. And to do that, I'm going to multiply both sides by 3, cancel out over here, and I'm going to have a 30 on the left and an x squared on the right. Now, the way to get rid of an x squared is by taking a square root. So I square root both sides, and we cancel out the square root and the square, and I get x. Now, when you take the square root of 30, you have a positive and a negative answer. We're going to go with the positive, the primary root in these cases, because we need our x's to be positive numbers if I were to plug them back in. So I'm going to go ahead and just get the decimal version of this. Square root of 30 would be 5.477. So if I round it up, I guess it'd be 5.48. And that would work for us in this situation. Now with example 7, I've changed it up a little bit. We're going to use the natural log instead of an log. Okay, that means our understood base is an e, so that's what's going to change in this problem. But when I look at it, I'm still trying to do the steps in the same order. So I'm first trying to get the log by itself. In this case, again, I have this big parentheses of stuff, but that's all with the log. It's not something I get rid of at this point. The 2 out front is something I get rid of. If it's in front of the log and there's just one log, I want to go ahead and divide by that. So I'm going to cancel that here. I'm going to have natural log of 3x minus 4. And then 7 divided by 2, I can leave as a fraction or I can write as 3.5. Either way. Now, I have the log by itself. I'm going to exponential form. This time, because it's natural log, remember that understood base is e. So I'm going to go e to the 3.5 power, or the 7/2 power. equals the 3x minus 4. And again, I can drop the parentheses when I get to this point. Remember that E stands for the number 2.718281828, and you have an E button in your calculator. Please don't think of this as a variable. Your variable is x. You're doing the same thing we're doing in every other problem with the x. You want to get it by itself. I need to get the 4 away from it and the 3. So I'm going to add 4 to both sides. On this side, I'll still have the 3x. I'm going to go ahead and type this into my calculator and get a decimal. So I'm going to move to Desmos and show you how to do it there. So in Desmos, when you type an E, the calculator part understands it as that decimal we talked about. But we wanted E to the 3.5 power. So I'm going to come down here to the power button and put the 3.5 in. And then I'm adding 4 to that answer, so I'm going to arrow down to the regular line and do plus 4. So that gives me 37.115. All right, so I put that here, and my final step is to divide that by 3 so that the x is by itself. So you can go back to Desmos or use your calculator and do that division. And I'm going to round off. This one comes out to be 12.37. It's not the exact answer because we've rounded off a couple of times, but it's close enough that you could figure it out in a multiple choice setting. And the answer kind of makes sense with what's going on in whatever situation you're talking about. So just be cautious that when you are rounding off, you are, getting a little bit off of the answer. So you may not see the perfect answer that you have found, the perfect answer is not exactly what you have found, but it's close enough you could figure it out if it was a multiple choice problem. Now, number 8 has several steps to it. If you'll notice, it's a little bit more complicated, but focus on what the log is. So in this case, the log is a natural log of this parenthesis. That is the part that I need to get by itself. So I need to get rid of the 3 and the 4. And you can't just subtract 3 minus 4. And the reason is because the 4 is multiplied with this log. And we have the order of operations that says we have to do multiplication before we can do addition or subtraction. So just working with these numbers and making them a 1 or a -1 is not going to help us out. It's not legal. I need to get rid of the 3 first. It's a positive 3, so to get rid of it, I need to add it with a -3. So I'm basically subtracting 3 from both sides. That doesn't get rid of this negative here. You treat that like a -4, and you have natural log 8x plus 1 equals 9. Now this is a number times the log you're trying to get by itself. So I need to divide by it. I'm going to divide by -4. So we cancel here. I have natural log of 8x plus 1 equals -9/4. Okay, the log is now by itself, so I want to turn it into exponential form. We have a base of e because we are dealing with a natural log. So I'm going to say e to the -9/4 power will equal 8x plus 1. So this again is something that I'm going to be typing into my calculator or into Desmos. So let's go ahead and do that. So in Desmos, I'm going to type in e and then use my exponent key and go to the -9/4. So I'm going to take several decimals here, so 0.10539. We'll go with that. So coming back to our problem, I'm going to replace that e to the -9/4 with this decimal. The more you round off, the more you're going to be away from the actual answer. So that's why I kept several more decimal places this time to show you that it would be a better answer. So I'm going to come up here and rewrite everything where I have room. 0.10539 equals 8x plus 1 is where we're at. And then you're back to an equation. So I'm trying to get this x by itself. I'm going to subtract 1 from each side. That's going to leave me with an 8x on this side. On the left, I'm going to have negative decimal 89461. And then I'm going to divide both sides by 8. Again, trying to get that x by itself. Cancel those out. And when I divide by 8, I get negative decimal 11182625. I'm going to stop here because I've already rounded off a lot, so I'm not real confident past that. So pretty good answer. It'll be close enough to something I can figure out or something I can work with. Moving on to example 9, I have another equation where I'm going to have to use properties. In this case, I'm using natural logs instead of log logs, and I have a plus between them. That is the product property. So when I back this up, I should have natural log of x times 3x. Now, that's a funny way of writing it. You can combine that, simplify it, and make that natural log of 3x squared, because it technically is x times x. And that's the better way to look at this problem. This is in the form that's ready for exponential because everything's away from the log. So I'm going to say e to the 14th power equals 3x squared. And again, I want to try to get this x by itself, so I'm going to start by dividing by 3. When I cancel those out, I get an x squared on the right. The e to the 14th divided by 3 is something that I either want to put in my calculator or put in Desmos. However you decide to get the answer, it should be 400,868.0947. And this one actually ended, so that was a perfect rounded decimal. I'm going to leave it like that. This x squared now needs to be an x. So to get rid of the square, I need to square root, and I'm going to square root both sides so that this cancels, and I have an x here. This one I'm going to type in. I get 633.14. And there's a 14492 after that, so if I needed more, I could consider what I needed for that particular problem. But that would be our answer. Okay, for our last example, there's actually 2 ways to approach this, and I'm going to approach it first the way that we've been doing all the rest of the problems. The log is by itself, so I'm ready to go with exponential form. So I know there's an understood base e, so I'm going to say e to the 17th power equals what's here is e to the x plus 5. And you should recognize this as one of those things that we did early on. When the bases match, we can set the exponents equal. So 17 will equal x plus 5, subtract 5, and x will equal 12. There's another way to look at it that we've also worked on. When you have the base here matching the base here, you can think of all of this as canceling and go straight to x plus 5 equaling 17, which puts you at the same place as you were here. You would just have to subtract 5 and get x equals 12. So it's 2 different ways to think about it. You just go with the one that makes sense to you at the time, because either one gets you to the right answer. And that concludes this lesson.